The first part of this problem asks us to find the effective spring constant of the water. Now we have a few different formulas for spring constant, but based on the variables we're given here, it makes the most sense to use the one that relates spring constant to frequency. So recall that frequency of an oscillation, because we are given the frequency, is equal to 1 divided by 2 pi multiplied by the square root of the spring constant divided by the mass. Now because we're looking for the spring constant here, and because all the other variables are given to us, we will algebraically rewrite this equation to solve for the spring constant k. So it's a bit of algebra here, but fortunately it's not too difficult algebra. We're going to multiply both sides of the equation by 2 pi to get this 2 pi out of the denominator. Then we're going to square both sides of the equation to get rid of this square root. And then we're going to multiply both sides of the equation by m to get k on its own. So what we find is that the spring constant k is equal to 4 pi squared multiplied by the mass multiplied by the square of the frequency. So now we're just going to plug in the values that were given to us into a calculator. So 4 pi squared multiplied by the mass, which is given as 52 grams. So we're going to convert to kilograms. So that is 0.052 kg multiplied by the square of the frequency, which was given as 3 hertz. And if we put that into a calculator, then we find a spring constant of about 18.476 newtons per meter, which we can round as 18 newtons per meter. That is an approximation. So that is the answer for part A. And now let's look at part B, which asks for the frequency we would expect the bottle to bob if we're looking at a water bottle with a new mass. So honestly, this part is kind of easier than part A, because we'll use the exact same equation we used in part A, only now we don't have to do any algebraic manipulation, since now the mass is given to us, and it's the frequency we're looking for. Though it is important that we did part A first, because we do need the spring constant to figure this out. But still, solving the problem from this point forward really is just a matter of plugging in our values. We just do 1 divided by 2 pi, multiplied by the square root of the spring constant, 18.476 newtons per meter, divide by the mass, which is given as 0.28 kilograms, and plug it into a calculator. And we find a frequency of about 1.3 hertz. And that is the answer to this problem. I hope this video helped you out. If it did, please consider subscribing, as that'll help me out in making more videos just like this. And if you have a request for a future video or a question about this one, leave a comment down below, and I'll try to help you out if I can. That's all for now, and I hope you have a lovely day. Bye-bye.